In section 2.5, we talked about factoring polynomials that are in standard form, and for all of the problems that we looked at in that section, they were all trinomials with a leading coefficient of 1. So the leading coefficient is going to be that number in front of the squared term, and we use what's called the Xbox method to factor those. So if in your 2.5 notes are the step-by-step instructions and explanation examples that we looked at. But now we're going to factor polynomials that have a leading coefficient that is not 1. And so the process that we use for this is going to be the same as what we did in 2.5, but now is when the box can really come in handy. So the first thing that I'm going to do is whenever I need to factor something, I'm going to see if I can factor out a monomial first. So the Xbox method will always work. But sometimes you can factor out a monomial before applying the Xbox method to make your life a little easier. You just have to pay attention. So for example, in this first problem, if I want to factor this, what the Xbox method tells us is that in the numerator we're going to put a times c, and in the denominator we're going to put b. But a times c is going to be a pretty big number, 18 times 12, and then b is going to be negative 33. So I'm probably not going to want to think of two numbers that multiply to give me 18 times 12 and add to give me negative 33. It might take a long time. So instead, I'm going to think, okay, can I factor this first, factor out a monomial or greatest common factor? So if I look at my coefficients, I have 18, 33, and 12. And 3 goes into all three of those numbers. So that's going to be the biggest, the greatest common factor. So if I factor out a 3 out of all of that, what I'll get inside the parentheses will be 6x squared minus 11x plus 4. And now I have this 3 on the outside, so I have to remember to keep it in my final answer, but 6x squared minus 11x plus 4 is going to be a little bit easier to factor. So like I said, in the top of the x, we're going to put a times c. So a times c is 6 times 4 in this case, which is 24, and then my b term is negative 11. So I have to think of two numbers that would multiply to give me 24, but add to give me negative 11. Well, if I think about the factors of 24, then we can write them out or not. We have 1 and 24. Those wouldn't work. We have 2 and 12, those wouldn't work. We have 3 and 8, and those do work, but because I have to add to give me negative 11, I'm going to use negative 3 and negative 8 for my factors. And then this is where the box comes in. So before, if I had a leading coefficient of 1, I just went straight to x minus 3 times x minus 8. But if we were to multiply all that out, we would get x squared minus 8x minus 3x plus 24, which is not what you started with. Like, that's not even close, really. So I can't just go straight to my answer. The box actually does come in handy here. So I'm going to put in my boxes in the top left, I'll put ax squared. So you don't need to use the original. You're just going to use the new, what you're factoring now, which is 6x squared, the one that's highlighted here. So we have 6x squared in the top left, 4 in the bottom right, and then I'm going to split my negative 3x and negative 8x, which were the factors I came up with. And now I'm going to look at the greatest common factors. So in my numerator, the greatest common factor for the coefficients is 2, and for the variables is x, so 2x is my GCF. Then if I look at my bottom row there, negative 3x and 4 don't have any numbers or variables in common, so my greatest common factor is just 1. And then I'm going to look at the first column here. So each of these have a 3 in common, the 6 and the 3, and an x. But I might notice this negative here, and so 2x times 3x is 6x squared, but 1 times 3x is not negative 3x. So I'm going to make this 1 negative, so that the negative 3x is satisfied, but that doesn't throw off the 6x squared. And that just leaves my last blank here. So 2x times what would give me negative 8x? Negative 4. And then we should see that it all works. So negative 1 times 4 or times negative 4 is positive 4, and negative 1 times 3x is negative 3x, and so on and so forth. So my answer here is going to be 2x minus 1 times 3x minus 4. And this is a lot different than what we would have gotten if we had said x minus 3 times x minus 8, which was not correct. And again, we can always check our answer by distributing and seeing what we got originally. But because I factored out a 3 in the beginning, I have to attach that to my final answer. So this 3 will go here, and that is my final answer. So it's the same process as before, but it is complicated a little bit by the leading coefficient. For the next one, again, I'm going to think, is there a GCF that I can bring out first? So I'll look at each of these coefficients and the constant at the end and think, is there a number that goes into all three? And in this case, 4 is the greatest common factor. So what will go inside the parentheses is 2x squared minus 9x minus 5. And I have to remember to keep that 4 in the end, but this is now a little bit easier to factor. So in the numerator, I will get negative 10, or in the top of the x, 2 times negative 5, and in the bottom of the x, I'll get negative 9. So two numbers that would multiply to give me negative 10, but add to give me negative 9. If I think about the factors of 10, I have 1 and 10 and 2 and 5. So it's going to be 1 and 10, but which one is negative? Well, this 9 is negative, so I'm going to make the 10 negative. That would give me negative 9 for my sum. And then I will fill in the box. So I have 2x squared in the top left, negative 5 in the bottom right, and then 1x and negative 10x. And then I'll look at my greatest common factor. So in the top row, we would have 2x. In the bottom row, x and negative 5 only have 1 in common. In the first column, we would have x, and in the last column, I need 2x to multiply by something to give me negative 10x, so that's going to be negative 5. And then we can check that it all works. 1 times negative 5 is negative 5, 1 times x is x, and so on. So my binomials are going to be 2x plus 1 times x minus 5, but I have to remember that 4 that I factored out at the beginning and put that in the front. And this is my answer. Next, we'll first consider again, do I have a greatest common factor? I'm looking at 5, 11, and 2. There is no greatest common factor, so I'm just going to go right into the factoring. So in my numerator, I'll have 5 times 2, which is 10, and the top of the x, and in the bottom of the x, I'll have 11. So two numbers that multiply to give me 10 and add to give me 11 are 10 and 1. And I'm going to fill in my box. So I'll have 5x squared up here, 2 in the bottom right, 10x, and 1x. So my top row here, 5 and 1 only have 1 in common, but I can bring out an x. In the bottom row, I can bring out a 2. In the first column, my greatest common factor is 5x, and in the right column, my greatest common factor is 1. So the answer here is x plus 2 times 5x plus 1. Another way to think about this is, instead of using the box, we can use these factors that we came up with and just write 5x squared plus, and then split that 11x into the two factors we came up with, which were 10 and 1x, respectively. And then, if we split this into two chunks, we can factor each of those binomials and write my final answer that way. So if I'm thinking about this, 5x squared and 10x have a 5x in common, so I'll bring that out in front, and what remains inside is x plus 2. And then x and 2 only have 1 in common, so I'll bring an x out in front, and what remains is x plus 2. And so because each of these has an x plus 2 in common, my final answer is going to be the sum of the other two terms, so 5x and 1. So 5x plus 1 by itself times x plus 2. So that's another way to think about it if you don't want to write the box. If that's confusing to you, then you can just stick with the box and that will be fine. If we keep going with a couple more examples, I'm looking at my greatest common factor. Doesn't exist here because 6, 13, and 5 don't have anything in common, so instead I'm going to use a times c, which is 30, and 13 on the bottom. So two numbers that multiply to give me 30 but add to give me 13 would be 10 and 3. And so I'll fill in my box 6r squared, 5, 10r, and 3r, and then go ahead with my greatest common factor. So we have 3r here, a 5 here, 2r, and 1. And so my answer is 3r plus 5 and 2r plus 1. And the last one for this section, 5x squared plus 15x plus 10. Is there a greatest common factor? In this case there is. It's 5. So I'll bring a 5 out in front and I'll have x squared plus 3x plus 2. And now this is really easy to factor because my leading coefficient is 1. So I'll have two numbers that add to give me 3 but multiply to give me 2. Would be 2 and 1. And because the leading coefficient is 1, I can skip the box and I know that it's going to be x plus 2 times x plus 1. I just have to remember that 5 out in the front. So next time we'll cover equations just like we did in section 2.5, and we'll use factoring to do that.